So today we are going to have a session on basics of solar PV installation. Under this topic, we are going to learn about the parameters of an solar cell. Already in the class, I had made you clear that group of solar cell is called as an solar panel. Group of solar panels is called as an solar array. Group of solar arrays is called a solar power plant. So you are very clear in this domain. Okay. So now we are going to see what are the parameters of an solar cell. So for example, the solar cell are grouped to form a solar panel. Okay. Now we will study about what are the parameters of a solar cell, or what are the parameters of an solar panel, which will remain the same answer for all the things. Okay. So what are those parameters? So this, sir. First parameter is short circuit current. Okay, let's try to see the parameters and slowly I will give the explanation and the importance. Okay, first parameter is short circuit current is the one parameter. Next parameter is open circuit voltage of the solar panel. Next one is maximum power of the solar panel. Next parameter is the maximum current of the solar panel. Next one is maximum voltage of the solar panel. Next one is fill factor. Okay, what is the need of fill factor and how fill factor is useful to us. Okay, next one is what is the efficiency of the solar panel. We will try to discuss all these 7 are called as the parameters of an solar panel or a solar cell or an solar array or an solar power plant. Generally our focus will be on the parameters of an solar panel. If you add, that will give an array. If you add arrays, that will give you the parameters of an solar power plant. Okay, so let's try to continue the session. First parameter is short circuit current. Okay, what is meant by this short circuit current? Next parameter is open circuit voltage. So in an electrical system, which will come first? Voltage. So the output of a solar panel is an AC voltage or DC voltage? DC voltage, and that voltage we are going to call it as a open circuit voltage. Okay, so what is meant first? In a solar panel, we have a solar panel like this. Let's try to understand. This is an 80-watt solar panel and suffixed with P. P represents peak value of the solar panel. P is nothing but the peak value generated by the solar plant. The output of a solar plant is nothing but what? DC supply. AC supply, DC supply. DC supply. You are very clear about that. So already we explained the concept of what is the name of this effect, how a solar panel will work. Photovoltaic effect. So based on the photovoltaic effect, when you give the photon energy or the light energy onto a solar panel, it will develop a voltage where this voltage is called DC voltage. The output, which is source, or where this is called as the source. What is the source we are going to get? Voltage. Where this voltage, we are not connecting to any load. We are not connecting to any load. Therefore, that is called as a open circuit voltage. This is the source. Effect is nothing but the current. Are you able to understand? In electrical, we will give the voltage is called as a source and current is called as the effect. Okay, that's how we get the formula. Current I is equal to voltage generated divided by the resistance offered will give you the effect. Okay, so voltage is nothing but that voltage. Since we are not connecting to any load, we are going to call this voltage as open circuit voltage. Sir, what is this importance of open circuit voltage? Open circuit voltage is directly proportional to the cell. If you use a good cell, for example, we are using a monocrystalline cell, which is the best cell available in the solar panels. Okay, so we have monocrystalline, polycrystalline and thin film technology, and you have one more type of technology. In all the superior technology, the best solar panel is nothing but monocrystal, which is made up of silicon. It's like a single crystal, that's what is called monocrystal. And if you use monocrystalline type of solar cells or solar panel, the open circuit voltage is greater. Voltage is directly proportional to the properties of the cell. If the cell is having good properties, automatically can have maximum output voltage, the first parameter. And how to measure the open circuit voltage? Generally we will measure in volts. or in millivolts. If it is a low graded, less than 1 watt, less than 2 watt, or less than 5 watts, you will get in terms of what? Millivolts. So what are the units of measuring the voltage? Volts or millivolts. The open circuit voltage depends upon the type of cell we are using. Either it may be a monocrystalline, polycrystalline, or thin film technology, and it also depends upon the cell technology and the temperature. So already I told in the class, a solar cell will work on basic concept called as standard test condition. Okay, it requires the two inputs. First input is temperature and another input is solar radiation. Another input is solar radiation. That should be in terms of power density. This is called solar radiation. Okay, so solar cell, in order to generate the voltage, you require two parameters. A solar cell require standard test condition, so it require temperature and requires solar intensity, where this intensity is called as power density or power density, where this will act as an input. This power density should be equal to, generally we will take in the lab as 1000 watt per meter square. So later I will make you clear why it is watt per meter square. Try to understand that a solar panel requires input as temperature and an irradiation or power density of how much? 1000 watt per meter square. When you give these parameters, then it automatically can generate open circuit voltage. That is called as the concept of temperature. How temperature affects the generation of open circuit voltage. That's how the cell technology. How many technologies we have? Monocrystalline, polycrystalline, and thin film. Based upon this technology, the voltage is going to change. So I think now you are clear about what is meant by an open circuit voltage. This is the voltage generated by the solar panel under which condition? Under which condition? Open circuit condition, when we are not connecting any load. For example, this is the condition where we are not connecting any load to the solar panel. The voltage generated is called as what? Open circuit voltage. This voltage is called open circuit voltage. Next parameter what we are going to have is nothing but a short circuit current. What is the name of this current? Short circuit current. This current is nothing but, the name itself it is saying that this is the current generated by the solar panel whenever the load is 100% short circuited. Okay, so when you make R is equal to 0, when you make R is equal to 0, what is there? Current is maximum. Maximum current will flow into the solar panel, or this is the maximum current that can be developed by the solar panel. So what is this? And the short circuit, what is the voltage? 0. Very good. So in short circuit, voltage is how much? 0, and current is how much? Maximum. Okay, these are the two conditions we have to verify. So short circuit current. So what is the short circuit current means? This is the maximum amount of current that can be generated by an solar panel. Okay, therefore I am going to say that if higher the magnitude of short circuit current, I can say better the cell and better the cell technology. Okay, if you use a good cell technology, what are the cell technologies we have? Monocrystalline. If you use a monocrystalline solar panel, then it can give the maximum possible amount of short circuit current. It depends upon the type of cell, and it depends upon the type of cell technology. Next one, short circuit current is generally measured in what? Current is generally measured in what? Amperes. If it's like 1 watt panel or 2 watt panel, then you will measure in terms of what? Milliamperes. Okay, next one, this short circuit current is also dependent on the radiation power density. Already I told what is input to the solar panel. One is temperature, next one is power density. The units of power density is 1000 standard. I am taking standard test condition, 1000 watt per meter square. So if you are having more radiation, or for example if the radiation is more, automatically the current is maximum. Okay, so just keep it in the mind. When you subject the solar panel from morning to evening, the solar panel voltage, for example you have taken a 100 watt panel, 100 watt peak panel, the output of the solar panel is how much? 12 volts. Take it an example, but current will change as per the radiation. For example, at morning you may have some 5 amperes current. At 10 o'clock you will have 6 amperes current. At 12 o'clock you have 8 amperes of current. Okay, so maximum current will be developed at which time? Afternoon only. At 2 o'clock also you will have 8 amperes. At 3 o'clock also you will have 8 amperes. At evening 4 to 5, at evening 5 o'clock you will have only 6 amperes. So now what you understood? With the variation of power density of the solar system, the current value is also going to change. But what is fixed? Voltage is fixed. voltage doesn't require solar radiation. As soon as you apply the solar radiation, the sufficient voltage is generated. Okay, so that is what the concept. Next one, the short circuit current also will vary with respect to the angle of the cell. For example, you have a solar panel like this. You kept the solar panel, you have an 0 degrees at the surface, and you kept the solar panel like this. Okay, therefore the current will be, let's take the maximum current is 10 amperes, it will generate 2 amperes. So if you increase the angle, sun is there like this, so automatically at this angle it is going to generate 8 amperes. And one more, 45 degrees, for example, rated is 10 amperes, it will also generate how many amperes? 10 amperes. Whenever the solar radiation is 100% incident on the solar panel, then how much current is generated? Maximum current. If the angle goes like this, okay, so maximum radiation cannot be incident. Automatically the current magnitude may decrease to 8 amperes. Like that, with respect to position of the solar panel, what is going to change? Current is going to change. With respect to power density, what is going to change? Current is going to change. And if you have high short circuit value, then we have to prefer a good type of solar cell.